time zone. So let's start on time today. I'm gonna go ahead and share my screen. Okay, got some new hardware to play with today. Gonna go ahead and do things on the iPad. Hopefully that will lead to more informative drawings. So welcome to the second session of linked lists. In the second session of most of the weeks, it's going to be typically dedicated to lab work or interactive work. So specifically, we'll still have some lecture, but I'll try to keep it short. So for example, today, try to keep it below 30 minutes to give us time for two big interactive sessions. And then we hope this gives you also opportunity to then finish the problems off and get ready for the hacker rank by Sunday. And then I'll send out a recap also, and we'll do that every week so that you can use that for review as the weeks go on. So speaking of interactive sessions and our focus on that for the second half of the week, I wanted to give observation and reminder of what we're trying to do in here. So I believe, and this is the same as the last time we were in the course, and actually the same as, you know, we give advice for many students preparing to do these algorithm interviews. And that's that what we're focused on here is improving our interview score. We give a long pitch about what that meant, why we call it a score, the gamification of it, etc. And we believe it can be thought of in terms of these three fundamental components, and they're ordered in terms of least focused on in the course to more focused on the course. So knowledge of core CS material is practically not focused on here. You had to have it in order to get into working on these problems. So we already expect you to know a number of things, linked lists, sorting algorithms, etc. The next one we believe you can work on, and a lot of the course is devoted to this, which is how to use effective problem-solving patterns. So focused on a subset of things to solve and get really good at those things and memorize a few of them that have to be memorized, and otherwise have a few techniques that you can just draw out of your pocket and get practice at drawing these techniques out, trying to apply them to your new problem, see how it goes. And we have a few metrics for testing that: the hacker rank, which is going to give you a score and it's required; the practice problems, which were specifically selected, well, you'll also get feedback on. So this is, in our opinion, very well calibrated for the course. The number three, which I believe is actually the most important in that it represents the biggest gap most folks have as they begin their begin their process of learning how to be successful at algorithm interviews, is skillful communication. And there's a number of reasons for that. It has perhaps less to do with you know, your background, etc., or just this isn't something we've practiced before and taught. But whatever it is, it's also very hard to measure. We don't have a metric for that. It's something that you have to, when we go into the breakout rooms, practice your social skills of not just chatting. It's not social skills of chatting, but social skills of how you work together. Because remember, I brought up that for most interviewers, the number one thing they're trying to measure is, do we want to work with this person? Will we be successful? Is it fun to work with them? Will I enjoy going to work every day with them and solving these problems? So that's what we practice on for the breakout. So that means the following kind of things. If you can turn your video on, turn your video on, because once we see video, we can interact with the person. It becomes much more real. You know, make sure you have, you know, no audio problems when you come into the breakout room. When you start working on problems, if you know a lot of stuff and you perhaps perceive you're more advanced in the room, don't go through and just answer everything. That's not helping the other people out, and so you're not necessarily, again, being think about how to be the best person to work with for that room. You're practicing at being good to work with. When it comes your time, give your information. This is also practice for you. But by the way, teaching oftentimes is a very good way to develop your skill sets even further, even after you've become kind of an advanced student. Okay, so those are a few tips. And also, by the way, speaking of audio, so during the lecture portion, please mute your microphone. I'm hearing a few microphones coming on. Unmute them once you get into the breakout room. But yeah, keep it muted as we're talking through this. Okay. So that is the reminder of, hey, today when we get in the breakout rooms, the focus of today, really that's your time to give it your all to solve these. So we'll have plenty of practice to do that, and the TAs and myself will help to remind you do that. But now back to linked lists. So in the last class, we already explored a number of the patterns, and hopefully you've seen the docs by now and have had time to review what we believe are successful techniques and patterns for these type of problems. We already explored the multiple pass technique. Two-pointer came up in, I believe, one of the delete problems, also used for cycles. Dummy head has already been practiced in terms of helping you clean up. Reversing was a big focus before. And today we'll discuss a little bit about applying this to a sorting algorithm, which is rare, but an interesting case. So linked list strategies that will almost always be used: pointer bookkeeping, and then umpire is our strategy for approaching all of the interview problems. And it's partly built out of helping you be successful at the social part of problem solving, which is discussing the problem, discussing where you're at, allowing people to give you helpful hints early on, and allowing you to figure things out early on too, before you get too far down the rabbit hole. So it's basically, don't go to code right away. And we're going to have a breakout specifically dedicated to practicing the different pieces of that. So in today's breakout, in case you didn't, so here's the course website. I'm sure you've already been looking at it. So these are one of the problems that we expect you to have basically finished by today. And now we're in session 2. And in session 2, we're going to be doing these 2 breakouts. This is actually misordered. So we'll have the mock interviews first, and those will be one-on-one sessions where one of you has prepared a problem, or both of you have prepared maybe one problem. If you happen to have prepared the same problem, no problem. Just pick another problem from either down in this umpire section, or perhaps one of these problems in this list that you haven't prepared. That way you both get practice solving a problem that you haven't seen yet. I'll explain this more as we get to the breakout room. So I think let's get to just a little bit of stuff I wanted to cover today. Yeah, so this sort list problem. So I wanted to just make sure I could show you my approach at pointer bookkeeping and visualizing some of these problems, since we didn't get to do a good job of that last time. Okay, so we were asked to sort. So we're told we want to sort. I got to work on my ability to hold this pen steady. So we got to sort a list that might be like one. Well, actually, I don't remember the example. Well, there it is. Okay, I have it over here. So let's just say, there we go. Okay, 4 to make it more interesting. So it's not sorted right away. 2, 1, 3 is the beginning example we're given. And then we're told to put it into sorting order. 2, 3, 4. And the umpire stage starts with understanding, and I discussed this a little bit. So even before we get to visualization and the pointer bookkeeping, we want to, why is that sticking up? we want to understand the problem. So that will include giving examples. So we already kind of repeated the example the interview gave us. We want to look for edge cases. So, okay, this was an even example. What happens in an odd example? Okay, well, it's not too interesting. That's the 1, 2, 4. Perhaps it gets interesting as we try to solve it. The one node case is very important to talk about for linked lists. So a bunch of examples. And I think a lot of you are so 1 goes to 1, are pretty good at thinking about these examples, I've noticed. But some other things you might want to think about are not necessarily examples, but questions that are particularly related to this problem, and then show your experience with these problems. So this is a good time to ask, can there be duplicates? So what about duplicates? So if you know things about sorting and you've run into this before, it's important to show that at this stage. Not only will that help you, so a duplicate would be a duplicate value. Not only will that help you make sure you're addressing the problem that they want, but it'll also show your skill and is actually signs, the more kind of relevant questions you ask, the signs that you are perhaps a more senior hire. So something like duplicate, something like knowing, are there value limitations? So knowing that these are always going to be integers, or perhaps no, it could be float, or no, it can have a cap on the value. That also can lead to different algorithms. And so the more questions you ask like this, and then can perhaps even show like things like asking, oh, what about stable, sorting, ability to stable sort, and what that means. Again, that gets you points, but is also telling them that perhaps perhaps you know a lot of breadth of the subject matter. Okay, so let's that's a pretty good understanding phase. So let's just get out of the way here. So we can work with this clean case. Okay, so then in the matching phase, so you want to discuss things like, okay, pointer bookkeeping. I said I wanted to show you that. That has to do with all linked lists, so it's definitely going to have pointer bookkeeping. And you can mention these things also to the reviewer. They may not know what pointer bookkeeping means, so this is maybe something to keep to yourself. But things like, it doesn't look like I need to worry about reversing anything. 2-pointer doesn't look useful. Multipass, maybe. So I like multipass. So yes, partly because since you already know certain sorting algorithms, you can imagine that knowing the amount of work that you have to do and how you might split the work up using some sort of divide and conquer approach, a multipass might be helpful to calculate things you'll need for doing that. Okay, so let's go ahead and, now we've got kind of a good idea of what we want to cover. Let's go ahead and try a prototyping out. So in this phase, when we use pointer bookkeeping, I want to keep the problem very visual, but start to use some ideas of code so that I'm understanding where the limitations of my solution are. So to refer to our previous session and sessions I've seen before, sometimes people keep it too high. There's this perfect spot that you need to be in. Some people keep it too high level, so they just sort of breeze through the problem and say, yeah, I'll just have a pointer and it'll walk through here, and it'll know that this other pointer's over there. Okay, I've solved the problem. And everybody maybe doesn't want to give you a hard time, so they say, yeah. Don't do that. Help the person out that's solving the problem and say, well, actually, I don't see how that solves it. Can you explain this? And so then you drop down a level, and maybe you drop down too far. Now you're like, okay, well, actually, so I have this function def, f, and it does exactly. Now you're coding, and that's too hard. So it's this spot in the middle that you need to be. You find this spot in the middle where you are thinking as if you're moving your drawing with some pieces of code, but not the whole thing. That's the best I can say about that. But the better you get at this, the better you'll be at, I think, coding in general, actually, so software engineering, but also specifically to these interview problems. So let's work on this problem then. So 4, 2, 1, 3. And so I've kind of already decided perhaps in my matching step, since there's only a few sorting ons, and we were also told, by the way, that we wanted it to be n log n complexity on the definition of the problem, as well as O of 1 space complexity. You should know from your, your theory, your CS theory, that there's really only a couple algorithms that, well, there's only a few algorithms that are typically interviewed about regarding this. So there could be many ways to sort, but in interviews, we typically want to see merge sort applied, quick sort, maybe different details about them, insertion sort for, this is not a good performance-wise, but sometimes, well, it can be if it's a very small list and you don't care about complexity. But those are kind of the ones that get thrown around a lot. And because of our time complexity, we can automatically route this one. And then quick sort, I don't really want to solve in this way, partly because I'm worried about the shuffling requirements with the linked list. So I just automatically think, well, let me try this first, merge sort. And so I'm already so it's okay to start off right away with some visualization, even if you're not comfortable with how you think it might go. So let's go ahead and say, well, I know merge sort is all about merging two sub parts of my list that I expect to be sorted. And one of the techniques of pointer bookkeeping that's also very successful is assuming some functions exist as you go about to solve the high-level function. So let's see what I mean by that. So let's say I'm coming through this list, and okay, merge sort means I assume two lists are already sorted. I'm going to merge that. Okay, so how can I apply it to this case? Well, I know that in merge sort, you also build up. So you want to build up from very small lists. So let's say I have very, very small lists of just one item here. And those are always sorted because they're individual nodes. So in this case, it's 4 and then 2. So just like these two numbers here. And then I just have to sort those. And so that turns that into 2, 4. And then you move on down the line. So you deal with this in one chunk. And then you deal with this in another chunk. In this case, this is 1 and 3. And these are both sorted. So then you apply some sort of merging algorithm to then produce this in the end, which is the same thing. And then you just keep moving on down the line. And we all have experience with that with arrays. So you can, just index this really easy. But the trick here comes in with linked lists. So that's where, you have to apply pointer bookkeeping to make sure you don't get lost. So we know we want to do this. So we know we need basically some sort of way to point to some area that we're going to be working on. And then the other part, so there's two lists, that we're merging together basically. And then we need to go and do more work as we move on throughout the rest of the list. So we might have, say, a left pointer here for the left side of the list. And then we can get a right pointer by moving forward some amount. And what's the amount? Okay, well, we know in merge sort, we actually start with some size. So say we have a size S, and in this case, it was equal to 1. So that's our first, we have, this kind of means sorted size. So the amount of the list that's already sorted. So, okay, we're going to move forward 1. So and oftentimes with pointer bookkeeping, it's like I keep the, remember you're almost debugging, so I keep the code here on this side, and then comments I kind of write on this right side here. So this is like comments as I'm coming down. So this might be a visual, comment. And then we have s equals 1, like initialization, almost kind of pseudocode here. And now I can say, well, R, I get R there by doing like, I call it a forward or move function that I'm just assuming exists. And what it does is it takes the current position, L, and then it just moves forward some amount based on the size, S. So now I have this right pointer here. And that's a part of a key of this pointer bookkeeping visualization for linguists. And for other algorithms, this is actually very useful, which is assuming certain functions exist that will help you out, so you don't have to get into the details of everything. So I'm pretty sure I know how to forward this, one hop. I could write this, and I can either save it for later to write to the end, or if my interviewer agrees with me, perhaps that it's so easy, he'll even let me skip that, and so I can just say, okay, well, forward exists, and I kind of understand the runtime complexity. Okay, so now we have L and R, and so our job will be to merge this. So I can again assume that there's some sort of function, let's say merge, and what its job is to do what I did here in this visualization, which was the 4-2 and turning it into 2-4. So it will do some sort of thing that takes two linked lists that maybe are part of the rest of the list. So it has to do it in a way that keeps the rest of the list unaltered. And I already know then, well, since I have to interact with the rest of the list, then I probably need to be pointing to the rest of the list so that any kind of surgery basically I do to this area here, I can maintain access to the rest of the list. So that's what part of pointer bookkeeping is about, is anytime you're doing a edit to some part, you should be like this part, you should be thinking, I probably need a pointer to keep track of the rest. And so I probably need something up here in the head, and then this is where the dummy pointer technique comes in. So say I create some D node, dummy, so it has the value D in it. Say we're allowed to have strings, or I could create some other integral value or something else to say it is dummy. And now I'll have a pointer D pointing to that dummy pointer. This technique you might not think of right away, but that's why we teach it to you, the dummy head, but it can really help out later on as you try to, once you write the code, you'll see it removes a lot of edge cases. Okay, so now I feel like I might be ready, and that merge might take in some function that takes in D, L, R. Actually, why am I limiting myself to that screen real estate here? I have the ability to move this over. L, oops, R, and then N. And it returns, I don't know, it probably returns the rest of what this list is. So, maybe we'll just set it to a new variable like T. Where's my eraser? T. And then later on, we will say that D.next goes to T now. So basically, it returns whatever kind of surgery it did here. So we apply that. So let's redraw. So that's the other part of pointer bookkeeping, is knowing when to redraw D. And now D.next is getting set. So this is D.next is getting set to whatever I return from merge. And the beauty of this function approach, or just a miracle function approach, as I say sometimes, is that you can just assume it does right now, because you don't want to figure it out. You just assume it does this sorted merge. And so whatever the sorted merge will return a sorted list between these two one-length node lists. So that would be 2, and then going to 4. And then you also assume, because you had given it the next pointer here, that it will appropriately do the surgery to then apply whatever the end of this list was to the rest of the work you need to do. And so most likely, in addition to T, so that you don't have to continue to, because otherwise now you'd have to jump ahead from T, sorry, it gave you T, which was pointing to this now. And you can either just choose to now start your algorithm by saying now L is equal to use the forward again, forward, and then T, and then 2 times S, because at this point you're going for it. But I think a better solution rather than using forward at this point is just assuming, since you gave N here, whoops, let me turn the eraser on. Since you gave N here to merge, that in addition to T, merge also returns the next N. So that then the next N will be pointing to here, which is whatever this in the end needs to point to. And then you can just say, okay, well then the lefts now will go to the next N. So your new left goes to the next N. And that's the other key to pointer bookkeeping, is you're trying to get your visualization to the point where you've gotten back to a condition you were in earlier. So you're now at a case where you have L pointing to the next, the beginning of more work you have to do. So you basically have gotten back to this position here, where you've done this work back here, the prefix of the list, and now you've gotten yourself back to a starting point like you were when you were here at the beginning of this prefix. Which basically gives you the indication of, you've solved the while loop that is probably here. There's some sort of while loop that you've created the guts for here. And so now you can start thinking, I'm starting to apply some code concepts like this while loop and this to bring this drawing to life, to bring it where the rubber meets the road. So it's not just a drawing, but I'm also having to deal with the limitations of code. Like in order to do a while loop, I have to have the exact same conditions I had before, which is that it has an L pointer and it still has an S. And so the next step it would do, if we go and do our, we don't actually have to do a new visualization here because we still have plenty of room here. So R would fast forward to, so it's this step that we're doing now. R is equal to fast forward LS. L is already there. We still know S. And so R goes here. Okay, and so the other case you want to jump to, so you can't spend too much time doing this. The other case you want to jump to is the end condition. So sometimes you can just guess at it. I like to guess at it in these early phases, as long as I'm having a pretty educated guess, because you can change it later on and you don't want to get hung up on figuring out the exact details. Again, you're playing the case of getting the right details, but not all of them. So I could just say, let's make fast forward such that, let's put a note here. So let's put a note here. Forward, can handle none input is fine, and I'll just return none. Okay, so what that means is that no matter when I call forward, if L is already pointing to none, it can handle that and just return none, which probably means that my while condition can be based on if there's just a right side of the list to merge, while R. And the reasoning for that is because, remember, the merge takes two sorted lists, a left side and a right side, and then merges them together such that the final list, which is twice as long, is sorted. and then it'll do it again for large list. That's how merge sort works, which you should remember. In the case where there is no right side, it should just return the left side. So we know the work is done because it's already sorted because the left side is over here. So we don't even have to call the merge algorithm. We can just exit our while loop then, so while r. And then finally, if you remember for merge sort, the next thing we want to do is go through S of we just did one length, so we assumed one length paths are sorted. Now we can assume, because we just did 1 plus 1 is 2, so it's always twice as long for the two sides. So S is now equal to S times 2. And so we know there's nothing special about this part of the merge sort for linked list, which is we just know that we have another, well, we don't need a comment there. We just know that we have while S is less than the length of the original list. Oh, we can't call length on the list again, so this is why we probably use multipath, so we just have length of the list as calculated. And that just comes from knowing your merge sort condition. Okay, so that is what I wanted to show you about pointer bookkeeping that I couldn't in the last class, namely that it's a right level of visualization between, so basically as long as these functions exist, so you don't have to solve everything. So merge, you will have to solve that in the interview, this merge part. But at the first pass of writing this down, you might want to use it as a function that exists. And in fact, that is a function that's going to be part of the homework. So you will make it exist, and then you will you can solve the rest of this algorithm. But we've used code, and as you can assume some things exist, but you still have to use those with code to sort of see how the rest of this exists. Okay, so there's other examples if you want to see this fully worked out. So after the session, you can go down here where I've recorded, there's just not enough time to do this much work in a quick overview that I want to give you. But how you would use a pointer bookkeeping to then go to fleshing out the code, the implementation. So this kind of gives it a little more long-winded, and then shows you how to dive into the implementation from that. I probably used different variables, and I used maybe a bit of a different scheme with this algorithm, but it should be pretty similar. And then the review phase, which is basically, which I didn't get to. So we're all very comfortable with implementation. That's the one thing we're trying to get you guys to slow down and not do as fast, but that's coding. And then in the review phase, you're going through your code and debugging, line by line, working through it. And these we'll get to in later lectures. I'm just giving you a sort of preview. Right now, we're going to be focused on the first 3 parts of Umpire. And then evaluation, where in the end, so you should always be thinking about complexity, both runtime and space. So runtime here, and then space complexity at the bottom. But evaluate in the very end, you should definitely do it as a recap of what's going on. Okay, so what we're going to do now is, it's not describing lectures. We're going to break out into mock interviews. So I didn't want to take up too much time, hopefully for that. So we have 2 questions here: swap nodes in pairs and rotate list. I shared this guide with you previously about how we would like you to conduct the interviews, and we really want you to conduct them as realistic as possible. You'll have 20 minutes for each interviewer. So one person chooses to be the interviewer, the other one chooses to be the interviewee based on pre-work they've done. So you should have picked one question beforehand to be the interviewer to understand that question. If not, that's okay. You can still be the interviewer and just ask inquisitive questions as they go along. But the idea was to be prepared to sort of dive in to make sure that the interviewee is expressing themselves fully communicating about their understanding and getting through the problem. So you'll have 20 minutes apiece, and then use that time as a hard cutoff. I do want there to be time pressure on this. And I'm helping you out because I've gone a little bit late, but you should experience the time pressure. As soon as the time is up, you stop and switch. 20 minutes hard for each person. If you don't get the problem, it's okay. That's how it works in the interview day. You won't get some problems, and you have to move on and be ready for the next problem. So let's go ahead and jump into the breakouts, and we'll meet back to recap for the next breakout.
I'll open the breakout rooms now.
Okay, are we back in the main room? Well, why is my video not showing up? There it is. Okay, so I only have 2 minutes to do recap here because I took up some of the other time. So we're going to now spend approximately 40 minutes. What I'd like to do is to go through the 3 problems that are in the umpire section of our session 2 breakout room work. And it says we want to do the full umpire. That will not be very possible in the 40 minutes. But what we really want to practice on is the U, M, and P of the, oh, are we having problems hearing? I can try to speak a little more. Okay. So we're going to focus on the U, M, and P of each of these 3 problems. This is going to be a breakout room of 4 people, perhaps a little less if we don't have everyone in there. But the idea is to rotate around the problems and rotate on the sections. So somebody will do the understanding and then perhaps hand off to the matching and then hand off to the prototype and do that with the next one. So again, the idea is you're really getting used to each of these sections being valuable. You're not just solving the problem. You're exploring these sections and solving these sections. So you might have to start off where somebody left off. Anyway, let's go through the UMP and really work at the level where you're convincing the other people that what you're thinking about is working, and everybody else, if they don't understand what the person just said, stop them so that you understand what it is. Don't just let them fly by saying, well, and then 2 pointers is just going to work. Okay, so let's break into the 4 rooms. You have 40 minutes, and then 2 minutes short of the end time, I'll recap everything.
All right, rooms are open.
Hello? Hello? Can you hear me?
Yes.
Oh,
Okay.
great. Are we doing the mock interview? I couldn't hear the instructor when I was transferred back in.
Oh, okay. We're going to umpire practice. I'm gonna try to assign you to a room.
Oh, we were supposed to do the umpire practice second? I thought, so I did the umpire practice first. Like 40 minutes ago or 30 minutes ago.
Oh, okay.
I don't know. I'll just do whatever you guys are doing. See.
Shanlin, can you join the breakout room? We have already sent you the invite.
For the last 2-minute recap here. Hopefully the way that you were treating this session was very faithful with the time that I mentioned ahead of time that I would like us to do. I was pretty tyrannical about it with my rooms where we cut off. So with the 3 questions, each person only had 12 minutes. And or if you were rotating around, you only devoted 12 minutes to each question. And you were really moving through those UMP sections to get as much as you could in those 12 minutes. So hopefully that gave you a little flavor of the balance where we don't want you to start prototyping right away. We do want to do the understanding and the matching, but you also need to be moving quickly. So that's really the toughest part of that is we're mixing this interview is all about in a social way, so socializing, working through this problem solving, but also doing it quickly because there's this time pressure. And that's gonna be easier as you have more time, especially with this framework. Right now with this framework, you have to like say, oh, now I'm understanding, now I'm matching. But that's just meant to, once it's ingrained in your head, you won't be doing that. And also, it's not something that you necessarily say to the interviewer, oh, I'm doing understanding now. No, this is just meant for you personally to be thinking as a framework for us to be practicing how you will do the problem solving. So great job overall in this first week. I saw a lot of good things, especially on the second session. I think we're getting better at doing these breakout room problem solving sessions. So good luck on the hacker rank. Finish as many practice problems as you can beforehand, and then feel free to go back over these. There was a lot of time pressure with this one, so go back over the problems we did today and finish them again. But again, do it in a time boxed manner. So when you go back to finish them, don't spend an hour on each one. Go back and give yourself again 20 minutes and try to work through it, working through the full umpire. Maybe give yourself 30 minutes for to do the full problem for some of these questions. All right, so I'll stick around for a little bit in case there's any chat questions, but we've reached the time. So great job.
Thank you.
Thank you.
Thank you.
Bye. Thank you.
Thank you.
Bye.
Thank you.
Thank you. Thank you.
Thank you.
Thank you.
Thanks.
Thank you. Bye-bye.
Thanks.
Thank you.
Goodbye, Tony.
Have a nice weekend, Tony.
Thanks.
Sure weekend, Tony.
Have a nice weekend, everybody, including the TAs. Tony, thank you, everybody.
Goodbye.
Tony, when do we meet in groups?
So do you mean the physical, like geolocated?
Location, like let's say New York, if you're in New York.
Yeah, have you already been setting up? I believe we are going to recommend people that are in your area, but I don't know if that's been sent out yet.
I think we filled out the survey or something.
It's been sent out already earlier.
I received a virtual group thing today.
Well, I mean,
Today?
is there much of a point to doing this? Because the breakout rooms are random, I take it. So we can't even work with the people immediately around us, can we?
Sorry. So I believe the question was about the different meetup when it's not in the breakout room. The breakout room is live right there, and that's going to be
want
random.
to study together? Is that what?
Yeah, we definitely recommend that in addition. So if you have the time, in addition, you should try to meet up. And some people, you're just going to be not around where other people are, so you won't be able to make that group. But maybe you can make it with, find one other person to do it with. Again, it's to give you time to practice that. Like if somebody asks you a question and throws you off, can you still, sort of move it along? But if not, we're definitely going to give you every week. We'll give you about an hour of doing that as well, twice. So.
I had a question actually. What we worked on was the partition list. And so the people that I worked with advocated for the dummy node strategy, but I just wanted to do null checks to see if we had initialized it or not. So why is the dummy node strategy better? And isn't it more complicated if you're in like C++ where you have to do cleanup for the dummy node?
Those are great questions. So yeah, you wouldn't have seen the utility of the dummy node up until now because I'm never coding yet. I haven't gone through and then tried to code up the prototype, because what the dummy node does is it basically catches edge cases for you, so you don't have to special treat things like what you're just saying. I have to do this null check. If you create a dummy node, so if you look in the guide that I described this, the basic pattern is the following. And in the partition list, what they were describing, one way to do it, which is probably how I would do it, is you create two dummy nodes, one for the beginning half and the next for the second half. And then the beauty of the dummy node is they're just a regular node like anything else. So you just treat them like a node and you say to the end, and then what you do is you chop them off at the end because they always exist. So they always have an X. And so it just makes those operations, once you get to code, you'll see, you just treat them like regular nodes. So you remove all these special cases in your code.
And then you just clean up them afterwards.
Yeah, clean up in memory.
Again,
I work in C++ all the time.
Yeah, so I think what you would do is you would declare it on the stack and then point to it, and then so that you don't have to delete it.
Sure, you could do that, or the heap is fine. Again, like a lot of these questions, like if you can get to a clean solution that you write fast, that's better. Even if you in the end have to say, well, then I might not do this, because I can recognize it, put stuff on the heap, and I kind of don't want to do that. Well, guess what? You just solve the problem really fast, and you tell them that you know about the heap and that you're worried about it, and so maybe you would do it a little bit more efficient later. And that's a better way. You're going to win more points there. You're going to be done faster. I always recommend that.
So either one would be fine. It's just a matter of whether we can explain it well. Is that
and fast. So if you can explain the other one with a lot of edge cases very quickly, easily, that's fine. But sometimes those edge cases catch up with you. Like I try to save every line I can.
The less thinking, the better.
Yeah.
Okay. Well, thank you very much for answering my question and for the session.